This is geometry, first day of Unit 8, talking about simplifying radicals. The need for simplifying radicals will come up in, obviously, geometry and definitely in Algebra 2 in the future. A radical expression is in simplified form if the following conditions are true. No perfect square factors other than 1 are in the radicand. A radicand is the value inside the radical. So we have this radical. We'll specifically call it a square root. And the radicand is the value inside the radical. So the 45 is considered the radicand. So it has to be simplified. No fractions, that should be an R in there, no fractions are in the radicand. And no radical appears in the denominator of a fraction. So you can't have a square root in the bottom of a fraction. We'll talk about how to get rid of that. So as we begin to simplify our radicals, it's really helpful if you think about your perfect squares. So here we'll list out our perfect squares. Of course, 1 is a perfect square. 1 times 1 makes 1. That's a perfect square, but that doesn't help us because you always have a multiple of 1. So that's not really an important one. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. 16 and 25, 36, 49. That's 7 and 7. 8 and 8 is 64, 81, and 100. Those are all perfect squares. So it's best when simplifying a square root to be using perfect squares. Not a requirement, but definitely helpful. So using these numbers, these perfect squares, which ones of these numbers divide into 24 evenly? Which one of these numbers divide into 24 evenly? 4 divides into 24 evenly. So 4 times 6. We're factoring 24 apart. We're using a perfect square to do that. So the square root of 4 is 2. So that's 2 root 6. And we simplified it. Now, some of you may notice that the square root of 6 can be broken down also. 6 is 2 times 3, but there aren't any perfect squares in 2 times 3. None of these numbers go into it, so we can't simplify that anymore. So we just leave it as 6. Because we don't have any perfect squares. Some people say 24, I can do that using 8 times 3. 3 times 8, that's 24. Well, I don't have any perfect squares there. But 8 can be broken down more. 8 is divisible by 4. So you do have a perfect square in 8. So just keep breaking it down. You have the 3. You have the 4 times 2, which makes 8. Since you know the square root of 4, square root of 4 is 2. And then you have that 3 times 2 left over. And that can be still your 6. So you can get the same answer either way. But it's definitely smoother to use a perfect square from the beginning. Let's try the next one. Square root of 20. Which one of these numbers divides into square root of 20? A 4 again. Just a coincidence, but it's 4. So 4 times 5. So you know the square root of 4. That's 2. 2 square root 5. And you simplified it. You're done. Let's say you didn't think about the 4 and 5. You just thought 2 and 10. That's the only thing you could think about making 20. Okay, 2 and 10 makes 20. Well, those are not the same number. They're not perfect squares themselves, but 10 can be broken down again. So maybe that'll help us. 2 times 5 makes 10. Hey, now I have a pair, because we're doing a square root. We want a pair of numbers. That's kind of like calling it 4. 2 times 2 is 4, and the square root of 4 is 2. If you have a pair of the same numbers, you pull it out as a 2. So that would be 2 root 5. You can do it either way. Let's try our next one. What number from our perfect squares divide into 45? And 9 does. 9 times 5. So you know the square root of 9. That's 3. So you have 3 root 5. And you simplified it. There's other ways to do it, but that's the way that's suggested. Use a perfect square. Now here's a tricky one. 72. What number divides into 72? 8 times 9 is a good one. So 9 we know is a perfect square. So we're going to pull that out. Square root of 9 is 3. And that leaves us an 8. But we don't get full credit for simplifying this one, because 8 is still divisible by a perfect square.
So 2 times 26.
So working with the 8, we can still break that down into 2 times 4. That's 8. And 4, we know the square root of 4. We know the square root of all of these numbers up here. So the square root of 4 is 2. So we have the 3, and then the extra 2 from the square root of 4. And we have the radical 2 left inside. So this becomes 6 root 2. Now you may have noticed, since we eventually had the 6 come out, if we put it in the radical and squared it, we could have used 2 times 36. 36 goes into 72. So 2 times 36 could have been a good way to have done it, and you would have right away took the square root of 36, which is 6, and you were done. That would have been the ideal way to do it. But the most common way is people to recognize 9 and 8, but not simplify the 8 because they think they're all done. You got to simplify all the way. When multiplying, you can only multiply like terms. And for radicals to be considered like terms, they have to be the same type of radical. They have to both be square roots. You can't multiply a square root and a cubed root. Well, lucky for you, we're not doing cube roots. We're just doing square roots. So we can multiply them. Radicals can be multiplied with other radicals. And then the constants can multiply other constants. But don't forget to simplify completely. So let's take a look here. We have root 3 times root 3. we can put both of those numbers under the same radical and call it 3 times 3, which of course is the square root of 9. And what is the square root of 9? 3. So what you may notice is that when you square a square root, you're going to get the number that was inside there. Square a square root, you get the number inside. Over here, we have square root of 6 times the square root of 3. You have an option. A lot of people like to multiply those out and call them 6 times 3, which is 18. But now you have to break down 18. And using 6 and 3 wasn't helpful. So you got to use a different set of factors. So sometimes that's more complicated. But if you realize that that could be 2 times 9, and the square root of 9 is 3, so 3 root 2, that would work. But let me show you another way. What I would suggest, rather than multiply the two numbers together, sometimes when you multiply numbers together, they get really big. No need to multiply two values together and make them large. You can just simplify what you got. What are your factors of 6? 2 times 3. Your factors of 3 are really just 3. We don't need to write the 1. That just gets in the way. So you have 2 times 3. That makes a 6. You have another 3 for the other prime number. Do you have a pair of the same numbers? There they are. In the square root, we're looking for 2 of a kind. So we bring that on in front. That's the square root of 9. A pair of the same numbers comes out in front, and you have the root 2 left inside. So either way you want to do that, you'll get the same answer. There's more than one way. Okay, so we come over here, and we have 7 root 10 times root 2. Well, you could multiply it together and call it square root of 20, and then break that down. That's not too bad. But I'd suggest just say 2 times 5, because that's what makes 10, times another 2. Do you have a pair of the same numbers? Of course you do. They're not next to each other, but it's still a pair of the same numbers. So you're going to bring those out in front. And you multiply that together. And you have 14 square root 5. Now we can take a calculator and we can check our work. You could say 7 square root 10 times square root 2, and you could get some crazy decimal for it. Never write the decimal. That's not going to be the right answer. 14 times the square root of 5, because that's what we simplified it to, should be the exact same decimal. So that's a way for you to check your work to be sure things are working out. Okay, over here, if you have two numbers on the outside of your radical, just like we had the 7 and the 2, if you have two numbers on the outside, we're going to multiply those. Now, some of you may say that 10 is factorable. 10 can be broken down. But 10 is not factorable by a perfect square. When you factor it apart, 10 does not factor into two numbers that are the same. So there's nothing for us to simplify. We don't need to write that one. This is our final answer. If you break down the 10 into 2 and 5, you don't have a pair of the same numbers in there. So to be able to pull one out, it has to be a pair of the same numbers. Another way to think about it is the number 10 is not divisible by 4 or 9, definitely not 16. Okay? Okay, our last topic is rationalizing the denominator. Rationalizing the denominator is when you move a root, like a square root, when you move the square root from the bottom of a fraction to the top. For example, when we have 1 divided by the square root of 2, you have a square root of 2 in the bottom of the fraction. That's an irrational denominator. To be in simplest form, the denominator should not have an irrational number. So we can't have a radical in the bottom of a fraction. To get rid of the denominator, the radical from the denominator, to get that radical away, we're going to multiply both the numerator and the denominator by the radical. So let's try that. Here we have a radical in the bottom. So what did the directions tell us? How do we get rid of that radical? We're going to multiply the numerator, the top number, and the denominator by the same radical. So since this is the square root of 3 on bottom, I'm going to multiply square root of 3 to the top and to the bottom. Notice that this would simplify to be the value of 1. So we're multiplying our original fraction by a value of 1. So we're not changing its value, we're changing the way that it looks. So now we're going to multiply straight across and straight across. So we're going to get 2 square root 3. Don't call that square root 6. And what's going to be on bottom? What's square root 3 times square root 3? You could call it square root 9. 3 and 3 is 9. And the square root of 9 is 3. Are we able to reduce the 3's? No. Because this is the square root of 3. This is a number times itself to make 3. So that's a value greater than 1 but less than 2. We can't divide that by the 3 and just cross them off. So that is all we've got. Let's try the next one. What do you see? How are we going to rationalize the denominator? Multiply the square root of 2 to the top of the fraction and to the bottom of the fraction. So then we multiply straight across, and that gives us the square root of 6 over root 2 times root 2. When you square a square root, you get the number inside. And remember, you cannot divide a radical by a whole number. You can't take the square root of 6 and divide it by 2 and call it the square root of 3. You can't do that. They're not like terms. Let's try this one. For the same reason, you cannot divide the 3 and the 12. But we can rationalize the denominator. When I multiply the top, I'm going to get 12 times the square root of 15. And when I multiply the bottom, I'm going to get 3. Now I have two numbers that aren't radicals that go into each other. That becomes 4 root 15. And if you want to check your work, you could check your work by saying 12 times the square root of 5 divided by the square root of 3. That would give me some crazy decimal. And then I can take my final answer and see if I get the same exact decimal. So you can check your work to see if your simplifying is correct. It doesn't do it for you, and you definitely don't write the decimal. Now over here, this has got a shortcut. We all love shortcuts. This is the square root of 21 divided by the square root of 3. These are both radicals, specifically square roots. They're like terms, so they can be divided. So you could call this the square root of 7 because 3 goes into 21 7 times. Now, many of you probably won't realize that. Maybe you'll just get stuck in the idea, I must rationalize the denominator. So if you do that, you'll say 21 times 3, which is the square root of 63, over the value of 3. And you may realize that 63 can be broken down into 9 times 7 divided by 3. Well, the square root of 9 is 3, so you have 3 root 7 divided by 3, and those 3's cross out. You'll get the same answer if you rationalize the denominator, but it's much quicker to use the division when it's appropriate. So let's look at number 20. Square root of 6 divided by square root of 2, those are the like terms. Don't divide the 8 by 2, but you can divide the 6 by 2. So that's 8 root 3. And very similarly, over here, you have 8 times the square root of 10 divided by the square root of 2. You can reduce the radicals. They are considered like terms. And that's 8 root 5. And you can even check that with a calculator.